In this video, we are going to discuss the conservative vector field component theorem. Now, I call it this just for the sake of the title of this video. This is not the official name for this theorem. It's just one of the theorems of vector calculus. So we can continue. We can start by stating this theorem. Over here we have the theorem statement. The theorem statement is as follows, okay? If f of xy is equal to p of xy in the I direction plus q of xy in the j direction. So this is basically a vector field. So if f is a vector field, that is a conservative vector field, and the components pxy and qxy have continuous first order partial derivatives in a region D, then throughout this region D, we have that the partial derivative of p with respect to y is equal to the partial derivative of q with respect to x. That's what the theorem states. So we're going to look at the proof of this theorem. We're going to go through the proof of this theorem. So let's go ahead. Let's start discussing the proof of this theorem. Okay. So obviously in the proof, we are going to suppose that f is a conservative vector field and that p and q have continuous first order derivatives in a region D. So let's write that down. So suppose that, so that's where we start. Suppose that f, which is equal to p xy in the I direction plus q xy in the j direction is a conservative vector field. Okay, sorry. So suppose that f is a conservative vector field. Right? And that P and Q, and that P and Q have continuous first order partial derivatives, first order partial derivatives in a region D. Okay, in a region D. So we suppose that we let that be the case. We let f be a conservative vector field and p and q have continuous first order partial derivatives in a region D. So that's what we start off with. That's what we have to start off with. So since f is conservative, there exists a function f such that the vector field f is equal to the gradient of this function. Okay, so let's write that down. Since the vector field f is conservative, there exists a function f. Okay, since f is conservative, there exists a function f such that the vector field f is equal to the gradient of this function f. Okay, so obviously this implies now that the components of the vector field F, P and Q are equal to the following. So we say this implies that P, which is the components, one of the components of F, P is equal to the partial derivative of this F with respect to X, and Q is equal to the partial derivative of F with respect to Y. Okay, because of the fact that the vector field F is equal to the gradient of this function F. Okay, so we have that P is equal to the partial derivative of F with respect to X, and that Q is equal to the partial derivative of F with respect to Y. So obviously you can also write this using this notation here. So Fx, and this over here you can write it with Fy. That's subscript Y. F subscript Y, and P is F subscript X. So you can also use this notation here. Now we have the following. Okay, we have the following implication from this. We can say therefore we now have, okay, therefore we now have, what do we have? We have this. If I partially differentiate P with respect to Y, if I partially differentiate P with respect to Y, that means I must partially differentiate this partial derivative F with respect to X. And obviously that will give me Fxy. Okay, and also if I partially differentiate Q with respect to X, that means that I must now partially differentiate F subscript Y with respect to X, which will give me Fyx. Okay, and since we said that P and Q have continuous first order partial derivatives. Okay, we said that. Let's go here. We said that we suppose that P and Q have continuous first order partial derivatives in the region D. Okay, so therefore we know that the partial of P with respect to Y, which is this, is continuous, and that the partial of Q with respect to X is also continuous. So therefore, by Clairaut's theorem, we can say therefore by Clairaut's theorem, okay, therefore by Clairaut's theorem, we have that the partial of P with respect to Y is equal to the partial of Q with respect to X.